Welcome to the deep dive. Today we're taking a really fascinating plunge into social web mining. And our guide for this is the source you shared, Mining the Social Web.
Exactly. Yeah, this isn't just about scrolling feeds. Think of mining the social web as like a practical handbook, almost a story, really. It starts you off gently, basic concepts, getting data, and then it builds up layer by layer towards some pretty sophisticated analysis techniques.
Okay, got it. A step-by-step adventure, you called it. So if this book is our map, what's our goal here? What's the mission for this deep dive specifically?
Right. Well, our mission, I'd say, is to pull out those key nuggets, the real aha moments from the book. We want to show you how, maybe surprisingly quickly, you can actually get a solid grasp of this whole field and highlight some of the maybe unexpected ways the book suggests for making sense of all that social data out there.
Getting past the noise, seeing the
Yeah.
patterns. I
Yeah.
like it. Excellent. So where does this story, this adventure begin? What's the big picture the book paints at the start?
It kicks off by framing the social web as this, well, enormous potential resource, a data goldmine, basically. It even brings in Tim Berners-Lee, the inventor of the World Wide Web. His view is that the web was fundamentally social from the start, a tool for connection, for collaboration.
That's a powerful starting point. It reminds you there are actual people behind all those clicks and posts. But it also gets really interesting because, while Berners-Lee had that vision, the amount of data now is just mind-boggling, isn't it?
Oh, absolutely. Matthew Russell, one of the authors, he really flags how the social web has, well, grown up to the
Mm,
point where even governments are thinking hard about data collection, usage, all that. It just underlines how critical it is to understand this information we're all constantly generating online.
right. And there are ethical considerations too, aren't there? The book touches on that.
Yes, it does. It acknowledges the power that comes with accessing this data and the responsibility. It mentions things like the UN Global Pulse Initiative using data mining for social good, which is important context. But it's always about balancing legal data gathering with ethical use, responsible practices, advocating for privacy.
A crucial balance. Okay, so the book sets the stage, highlights the potential and the responsibility, then it gives us the tools to actually explore this landscape. Where does it start, practically speaking?
Yeah, it's very hands-on. It focuses right in on the specific tools and techniques you'd actually use. Python is definitely central. Lots of Python libraries, APIs. It gets you doing the analysis yourself.
Python. No surprise there. Seems like the lingua franca for data science these days.
It really is. And a great thing the book does is point you to GitHub for all the code examples. They keep it updated too, which is fantastic. Means you're not working with outdated stuff. And it encourages collaboration, building on what's there.
That's super useful. And specific libraries, does it highlight any particular ones?
Oh, yes. Pandas gets a big mention. It's pretty much essential for organizing data into, like, tables. Makes manipulation much easier.
Pandas, right. Rows and columns of data tamed. And where do you actually do this work? What kind of environment does it recommend?
Jupyter Notebooks. Strongly recommend it. They're brilliant because you can mix your Python code, the output, your notes, visualizations, all in one document. Makes the whole analysis process way more fluid and, honestly, easier to understand later.
Okay, so we've got the why, this data goldmine, and the what tools like Python, Pandas, Jupyter. Let's get into the how. Can we dive into some specific platforms? The book covers quite a few, doesn't it? Starting with, say, Twitter.
It does. Twitter's interesting. The book calls it more of an interest graph than a typical social network. Because of that asymmetric following model, right? You follow someone because you're interested. They don't have to follow you back. It sort of feeds our natural curiosity.
And that makes perfect sense. You curate your own information stream based on interests.
Yeah.
So the basics first. So the book explains things like tweets, timelines.
Exactly. Defines tweets, those short messages. And timelines clarifies the difference between your home timeline, which is the mix from everyone you follow, and a specific user timeline, which is just that one person's tweets. Simple stuff, but important grounding.
And to get this data, we need the API. What exactly is an API in this context? Layman's terms.
Huh? Okay. Think of it like a specific door or window into Twitter systems. It lets our program, our Python script, ask Twitter for specific information in a structured way. Like, give me all recent tweets mentioning this hashtag. The book makes it clear you need a Twitter account to get the key to open that door.
A digital key. Okay. And the data comes back in. JSON.
Yep, JSON. That's the standard format. It's like a structured text file, pretty readable for both humans and machines. Well, more for machines. Think of it as data organized with labels.
Got it. So can you walk us through an example from the book, Mining Twitter in Action?
Sure. One example they use is mining tweets with the hashtag mentions someone important for you. It shows you how to grab the tweet text, pull out any at mentions, other hashtags, and then use a neat Python tool called collections.counter. It just counts things up, so you quickly see which names or hashtags popped up most often.
Ah, frequency analysis. Simple but powerful for finding the main themes or people. And didn't mention something about lexical diversity, word variety?
Yes, lexical diversity, it's basically a measure of how many different words are used compared to the total number of words. In that example, they found the at I mentioned names had high diversity, lots of different people mentioned. Makes sense. But the hashtags were less diverse, mostly sticking to the main one. It shows how the conversation spread out person-wise, but stayed focused topic-wise.
Interesting nuance. What about retweets? They're fundamental to how info spreads on Twitter.
Absolutely. The book covers analyzing those two, both the official retweet button kind and the older style, where people manually put RT at username in their tweet. To get the full picture of spread, you really need to look at both.
Right, because people still use both methods. And visualizing this, turning counts into charts.
Yep, data visualization, essential. The book introduces matplotlib, a core Python library for plotting. It shows how to create histograms, those bar charts showing frequency right inside your Jupyter notebook. And it even mentions using logarithmic scales on the charts. That helps when some things are way more frequent than others, makes the less frequent stuff visible.
Very practical tips. Okay, let's switch gears. Another giant. Facebook. How does the book approach mining data there?
Facebook is centered around its Graph API. The book describes it as this massive information store, but it immediately highlights the privacy aspect. Facebook's quite locked down comparatively, so it's always this tension, this balance between accessing data for analysis and protecting user privacy.
Yeah, that's a constant theme, isn't it? Data access versus privacy. Did the book mention the Open Graph protocol too?
It does. Open Graph is what lets web pages become sort of objects within Facebook's network. It's why you get those nice previews when you share a link, the image and title. It also mentioned Facebook Graph Search, which actually isn't available anymore, but the core idea of that interconnected social graph is still relevant.
Okay, so an example of Facebook analysis from the book.
One example looks at public Facebook page engagement. Likes, comments, shares on posts. It uses those pandas data frames again to organize everything. Artist pages, post interactions. Then it shows how to make bar charts to see, for instance, which posts got the most likes or comments. Pretty straightforward visualization.
I remember seeing something called relative likes in that section. What was that about?
Ah, yeah, that's quite insightful. Relative likes isn't just the total number of likes on a post. It's the number of likes divided by the total number of fans or followers that page has. It gives you a better feel for actual audience engagement percentage-wise.
So a page with fewer followers but high relative likes might actually have a more engaged audience than a huge page with low relative likes.
Exactly. It's a smarter way to compare engagement across pages of different sizes. It normalizes things.
That's clever. Okay, what about a platform that's heavily visual, like Instagram?
Right, Instagram. The book explains accessing its API too. You need to register an application first, usually. And again, the data often comes back in JSON. Contains metadata timestamps, captions, user info, plus links to the images themselves. It also mentions pagination, how APIs give you data back in chunks or pages if you ask for a lot.
Makes sense. And since it's visual, image recognition comes into play. That sounds pretty advanced.
It definitely touches on more advanced territory there. It introduces the basic concept of neural networks. These are computing systems inspired by the brain, good at learning patterns from data. It even includes a simple example using scikit-learn, another Python library, to build a basic neural net that recognizes handwritten digits, just to illustrate the idea.
Wow, okay. From counting hashtags to recognizing images. That's quite a jump.
It is. And it doesn't start there. It then shows how you can leverage pre-built powerful tools like Google's Vision API. This API uses Google's own complex models. You can just send it an image, and it sends back labels dog, car, beach, or identifies objects. The book suggests you could use this to analyze your Instagram feeds, see what kinds of things you photograph most often.
Automatically categorizing your photos.
As well.
Very cool. Let's shift again. Professional sphere, LinkedIn. How do we mine that?
With LinkedIn, the focus shifts to analyzing your professional network. The book introduces techniques for finding clusters of similar connections, maybe based on their job titles. This involves calculating similarity between strings, between the text of different job titles. It mentions Jacquard distance as one way to do this.
Jacquard distance.
Mm-hmm.
Okay, break that down simply for us.
Sure, imagine two job titles as sets of words, software engineer and senior software engineer. Jacquard distance looks at the words they don't share compared to the total unique words across both. A low Jacquard distance means they share more words, so they're more similar. Software and engineer are shared here. The book shows using this to group connections with similar roles.
That makes sense. Finding patterns in your network based on roles and mapping locations. I think that came up too.
Yep, using a library called GOP. You can take company names from your LinkedIn connections, feed them to GOP, and it tries to find their geographic coordinates. Then you could plot these on a map, maybe using Google Earth, to visualize the geographical spread of your network.
Literally seeing where your connections work. Neat. But I recall the book mentioning a potential issue with some of these methods. Computational cost.
Ah, yes. Good point. Especially with things like clustering, where you compare everyone to everyone else. Comparing job titles for similarity across hundreds or thousands of connections, that takes time. The book mentions this computational complexity, calls it ON2, meaning it grows quadratically with the number of connections in. It even briefly suggests solutions, like maybe analyzing just a random sample of your connections if the full set is too large.
Practical considerations. Okay, so we've looked at specific platforms. What about just plain text,
Rue.
like from websites or files?
Right. The book covers mining text files too. A key first step it emphasizes is cleaning the text, especially if it comes from web pages, which are full of HTML code, menus, ads. It introduces Beautiful Soup, a Python library specifically for parsing HTML and pulling out just the actual content text.
Yeah, you don't want to be analyzing HTML tags instead of words.
Exactly. And once you have clean text, especially if you have a collection of documents, the book introduces a really important concept, TF-IDF.
TF-ADF, okay, that sounds important. Term frequency, inverse document frequency. What's the core idea?
It's a score, a number, that tells you how important a word is to a specific document within a larger collection or corpus of documents. It balances two things: how often the word appears in that document, term frequency TF, and how rare or common that word is across all the documents, inverse document frequency IDF.
So a word gets a high TF-IDF score if it's frequent in one document but rare everywhere else.
Precisely. It helps filter out common words like the, is, and, which appear everywhere but don't tell you much about a specific document's topic. TF-IDF highlights the terms that are uniquely characteristic of that document.
Very useful for finding key terms automatically. The book also mentioned finding words that often appear together, right?
Yes, collocations, or you might just call them word pairs or bigrams. It shows using NLTK, the Natural Language Toolkit library for Python, to find these. You look for pairs that occur together more often than you'd expect just by chance. It even brings back that Jacquard similarity measure as one way to rank how strong the association between the two words is.
Interesting. And moving beyond just words and pairs, when mining web pages, the book delves into natural language processing, or NLP.
It does. It talks about web scraping again, mentioning Boilerpipe as a tool specifically designed to extract the main article text from messy web pages. And web crawling, systematically visiting pages on a site by following links, like a search engine spider does. Breadth first search is mentioned.
Loading your own little data set from a website.
Kind of, yeah. Then it covers fundamental NLP tasks using NLTK, things like sentence segmentation, figuring out where sentences end, tokenize, and tokenization, breaking sentences into individual words or punctuation, word tokenize, plus removing stop words, those common filler words, and then doing frequency analysis on the remaining meaningful words.
Standard text prep pipeline. I remember seeing something about automatic summarization, Loon's algorithm.
Yes, Loon's algorithm. It's a fairly straightforward method for summarization based on word significance. The idea is to calculate significant scores for words, maybe using frequency, ignoring stop words. Then you score each sentence based on the significance of the words it contains. The sentences with the highest scores are assumed to be the most important and are pulled out to form the summary.
Clever. Using word frequency to guess sentence importance. Did it touch on anything more complex, like understanding relationships in the text?
It briefly mentions entity-centric analysis and the challenge of extracting relationships like subject, predicate, object, triples. Company X acquired company Y. It flags this as a much harder NLP problem. And importantly, it also introduces metrics for evaluating how well your NLP analysis is doing: precision, recall, F1 score, ways to measure accuracy.
Good to know how to check if your analysis is actually working well. Okay, shifting focus slightly again. Email. Mining our mailboxes. That feels quite personal, but also potentially rich in data.
It really is. The book frames email archives as almost a foundational source of social data, often overlooked. It explains how to convert mail archives into a standard format called mbox, common in the Unix world. Then you can use Python's built-in mailbox package, again often paired with pandas data frames, to slice and dice the data.
What kind of analysis can you do?
Things like querying emails within specific date ranges, identifying your most frequent senders or recipients, visualizing email activity over time, basic but potentially revealing patterns about your communication habits.
Fascinating. And one more platform, GitHub, the social network for coders.
Yeah, GitHub is treated as a social coding platform, a mine of data about software development collaboration. The book covers using the GitHub API to get data about users, repositories, interactions like starting a project. It then shows how to model these connections using networks, a Python library for creating and analyzing graphs or networks.
So you can map out who follows whom, who stars what repository, like a social network map.
Exactly. You can build property graphs where nodes are users or repos, and edges represent relationships like follows or contributes to. Then you can apply graph analysis techniques, calculating centrality measures, for instance, like degree centrality, how many connections a user or repo has to find influential hubs in the network.
Identifying key players or projects. What else on GitHub?
Building interest graphs based on who stars which repositories, or analyzing the diversity of programming languages used by followers of a particular user or project. Lots you can explore.
Seems like a whole ecosystem in itself. Now, I remember seeing a big section called the Twitter Cookbook. What's that about?
Ah, yes. The cookbook section is super practical. It's basically a collection of specific recipes, ready-to-run code examples for common Twitter tasks.
Like what kind of recipes?
All sorts. Securely authenticating with the API using Oath, saving the JSON data you get back, storing it in a database like MongoDB, finding the most frequent hashtags, mentions, or URLs in a set of tweets, harvesting lists of people who retweeted something, analyzing friends and followers, like finding who you follow that doesn't follow you back, using set operations.
Oh, that's useful. Or potentially ego bruising.
Huh, maybe. Also, recipes for crawling the friendship graph, mapping connections out from a starting user, analyzing tweet content itself, lexical diversity again, average words per tweet, even applying that Loon's algorithm we discussed earlier to summarize a user's tweets or their favorite tweets.
Wow, that sounds incredibly comprehensive. A real toolkit for Twitter analysis.
Yeah.
And you mentioned OAuth for access. Does the book explain that too? Security is key here.
It does. It includes a primer on OAuth, explaining the basics of both OAuth 1.0a and the more common OAuth 2.0. These are the standard protocols websites and APIs use to let applications access user data securely without you having to hand over your actual password. It's essential background.
Absolutely essential. Okay, we have covered a ton of ground here. It's really clear that mining the social web provides this incredibly rich toolkit for understanding online behavior, trends, connections.
Absolutely. It really demonstrates the power you can unlock and how quickly you can start gaining genuine insights from all these different online sources if you have the right tools and techniques.
So as we wrap up this deep dive based on mining the social web, what's a final thought for our listeners to chew on?
Well, I'd say start thinking about how you could apply some of these ideas, even the simpler ones, to areas you are interested in. What questions pop into your head about online communities or trends you follow? And maybe ask yourself this. Considering all these platforms and techniques we've touched on, from Twitter sentiment to GitHub networks to image analysis, what specific corner of the social web are you now most curious to explore further? What data might hold answers you're looking for?